Hello, everyone. Thank you for joining us today. I hope that you are having a great day so far, and we're going to jump right into our presentation on the US EPA changes to the AERMOD modeling system that came out just this past week. First, let me introduce myself. My name is Michael Hammer. I am a senior product specialist here at Lakes Environmental and a certified consulting meteorologist. I wear a couple different hats as part of the Lakes Environmental team. I help oversee our commercial software product development, help to plan upcoming releases of our commercial software products like AERMOD View, CalPuff View, CalRoads View, and the like. I also have my hands in our meteorological data processing, helping oversee that unit to get good quality MET data out to all of our air quality modeling users. And I also help with our technical support. Many of you may have seen my name in your email replies that you've sent to us over the years. I'm really happy to be part of the Lakes team, been here for several years and been doing air quality modeling for even longer than that, and have been part of understanding the AERMOD modeling system now for quite some time. Of course, here at Lakes Environmental, we do a number of things like our commercial software products, AERMOD View, CalPuff View, and others that you may be familiar with. We also offer customized IT solutions, our Aquamis cloud system. We've given a number of webinars about that over the past few weeks, and we'll be doing a couple more here as we go through the summer. So keep your eyes peeled for more webinar announcements about our Aquamis cloud solution. And of course, our training products, air modeling, risk assessment, and more, given all over the world and throughout the year. But we are here to talk about the AERMOD modeling system today, the preferred air quality model for near field impacts in the United States per the Guideline on Air Quality Models, or Appendix W. Now, many of you may be aware that Appendix W underwent some revision in the most recent years, culminating in the 2017 promulgation of a brand new guideline on air quality models. And as part of that promulgation, there was a new version of the AERMOD modeling system that was published way back at the beginning of 2017. And most of the executables were updated. So what we're dealing with now are further updates to the AERMOD modeling system. AERMOD is, of course, developed and published by the US EPA. They control all of the code, all of the executables, and they publish that on their website. Once it is made publicly available, groups like Lakes Environmental come and we make our graphical user interface for the AERMOD modeling system so that it is easier to use for most air quality modelers. AERMOD is made up of a number of components. You have the AERMOD model executable itself, represented here in the middle, into which you put in your sources of pollution, locations where you want to calculate pollutant concentrations, and a few other background parameters to calculate the actual air quality concentrations of pollutants. But in addition to the AERMOD model, there are a number of preprocessors involved, like to the left we have AERMET, because you have to process MET data in order to input that MET data to AERMOD. And AERMET also uses additional preprocessors, AirSurface and AERMINUTE. We have the BPIP prime program, into which we put in building geometry so that we can estimate building downwash impacts on releases from point sources. And then we have the AERMAP preprocessor, which reads in digital terrain files and puts elevations into receptors and sources and other model objects that exist within our AERMOD project. So all of these components are coded and developed by the US EPA. And whenever there are updates to those, we have to then update our air quality projects accordingly. Now, on April 24th, the US EPA published updates to the executables and source code for AERMOD, AERMET, and AERMAP. All three of these now have updates, and so they, because they are published on the US EPA website, become the official regulatory versions of the models. They replace any existing version that was out there previously. These new versions were dated 18081. 18081, a nice mirror image number there so that it's easy to remember, 18081. And for those of you who weren't aware, the dating system is the 2-digit year and 3-digit Julian day. So these executables were finalized by the EPA back on March 22nd of this year. And then it takes them several weeks to publish all of the documentation and make model change updates available for everyone so that everyone's aware of what the changes are. And that's where we're going to be spending the rest of our webinar here. We're going to be talking about what these specific changes are to each of these executables so that everyone has a good understanding of what's going on. First, we have a couple system-wide changes. So these changes apply to all three executables, AERMOD, AERMET, and AERMAP. First, there are now separately published executables for 32-bit and 64-bit operating systems. Of course, 64-bit operating systems have become a lot more common in today's hardware. It's very common to find operating systems that are 64-bit. Just get those commercially from any hardware vendor. And because of that, 64-bit operating systems offer a little more functionality in terms of the way the files are managed and in terms of the processing speed. So if you have a 64-bit operating system, check your system properties if you're not sure. You can look at your Windows properties, and they will tell you there if it's 32-bit or 64-bit operating system. So check your system properties, and if you have a 64-bit system, you can use the 64-bit executable. Otherwise, you'll stick with a 32-bit. You can also use the 32-bit on a 64-bit system. Another system-wide change was the allowance of user-defined input file names. So in previous iterations of the models, you would have to rename your input file to match the executable name. So if you were running aermet.exe, you would have to have your input file named aermet.inp. Same with AERMAP, same with AERMOD. If you tried to pass an input file that wasn't one that had the expected name, then it would issue a fatal error message. So now you can just pass through directly as shown here on the screenshot, aermet.exe. This file is ex01_s1.inp. It's just one of the sample files that accompanies the AERMET executable as part of the US EPA's publishing, and the file runs automatically. Specific changes to AERMET and AERMAP were very minor. There was one minor code change in the AERMAP executable, which made it more viable for Linux compilations, not really something that the majority of users are going to be too concerned with. In AERMET, there were 3 small bug fixes, one about identification of liquid versus frozen precipitation when reading National Weather Service data, a fix for a not a number issue in the Bulk-Richardson on-site pathway scheme, for specific situations of calculations where Z over L was greater than 0.7, then there would be NaN values written to the SFC and PFL output from AERMET, and that has been resolved. And then just some cleanup of the surface pathway quality assurance routines. All of these changes to both AERMAP and AERMET are internal code changes, really do not change anything about the way you're going to interact with the models. You can even drop in the new AERMAP and AERMET executables to your existing projects and rerun those without issue. And in a little bit here, I'll show you a demonstration using our software product, AERMOD View and AERMOD View, to do just that. The AERMOD changes were a little more extensive, and I'm going to start with bug fixes to AERMOD. Now, the majority of these bug fixes, again, are internal code changes, so they're not necessarily things you will have to change about an existing project or even when you're running a new project, but these could lead to differences in concentration as you rerun your model. So if you do see changes in your modeled concentrations when running the 18081 model executables, these could be some of the reasons why. First up is the prime downwash receptor bug. So when running with prime, which is the building downwash routine, there was a code change made in the old 16216R model executable, which incorrectly set the surface layer dispersion term to 0 in unstable conditions for all receptor heights. that really shouldn't have occurred because it was supposed to be limited to receptor heights that were less than 1/10 of the mixing height. So this has been corrected. Now, in a lot of cases, unless you have really high flagpole heights or really, really low mixing heights, most of the receptors are going to have the surface layer dispersion term correctly set, but there could be some instances where you see changes in running 18081 versus the older model versions. Another bug fix involves the SO2 pollutant half-life for urban groups. In previous runs, or in previous iterations of the model, the 4-hour half-life that was supposed to be applied to SO2 when urban groups were enabled was not being properly applied when the non-default model options were being used per the control pathway. That has been corrected, so now in all model runs, whether there's regulatory default options selected or non-default options selected, you'll see this 4-hour half-life for urban SO2 analyses. Some minor bug fixes, one about the minimum wind speed being applied to vector wind speeds. That's just a little checkbox within the meteorology pathway. Again, nothing you necessarily have to do. It just is applied now per the correction in the code, and some additional rain checks on the ARM2 nitrogen dioxide processing routine. Additional bug fixes include the annual post file. You may remember this, users of AERMOD View, as the report maximum annual average for each MET year option. That's on the control pathway. It's been enabled since the 15181 AERMOD executable. And in all versions up till now, the annual post file would report maximum annual averages for each year from a multi-year run, and it would also include the multi-year average. In this release, they've removed the multi-year average from the post file itself. If you need the multi-year annual averages from a run where this option is enabled, you can get those from the plot file output instead of using the post file output. A bug fix for dry deposition velocity. So for cases where you were modeling with dry deposition, there was an incorrect seasonal assignment. The winter with snow was not being applied correctly, and it also is related back to the bug about identification of frozen versus liquid precipitation in AERMET. So that was done for or fixed so that ozone cuticle resistance could be properly used within those equations. And then some updates to the output file. The buoyant line summary table is now included with the output file. And then there was background sector information that was used correctly within the model, but then incorrectly reported within the output file. So the summary tables have been adjusted accordingly. Now we're going to take a look at model enhancements. New features, new keywords that have been added to the AERMOD model that you'll eventually be able to take advantage of. And the first of these enhancements is the alpha option flag. Now, in prior releases of the AERMOD model, there were beta options. These were non-default regulatory options and would typically require approval. And they were options that were put into the model mostly for testing purposes. With the 18081 model changes, there are now two hierarchies of these types of options. The first is the new alpha option flag, which is applied to draft enhancements still in testing status. These are kind of things that people have proposed, but not necessarily gone through full scientific review of, and they're being added to the model so that additional users can take the opportunity to test them out for themselves. The beta option flag or keyword is now in 18081 going to be reserved for options that have undergone peer review and full scientific testing so that they can be then considered for promulgation into future versions of AERMOD. So if something graduates from an alpha to a beta, then the expectation is that eventually in a future model release, it would graduate from a beta option to a full regulatory default option. Now, in earlier versions of the AERMOD model, there were three primary beta options: the PSD credit keyword, low wind 1, low wind 2, and low wind 3, and the adjust U star method. All of those were beta non-regulatory default options. With the 18081 model update, they've mostly been reclassified. PSD credit is now an alpha option because it is still being tested and is still considered a draft addition to the model. The 3 low wind options, 1, 2, and 3, have been replaced with a new alpha option called low underscore wind, which we'll talk about on the next slide. And the adjust U star implementation has been further refined. It was made partially a regulatory default option in 16.2.16R, but the beta status was still held for some cases. Now the beta option has been removed entirely, and adjust U star is considered either regulatory default or nothing at all. A fatal error will be issued if it is improperly used. And of course, adjust U star also involves some AERMET usage, so you have to pay attention to how that option is used within AERMET to make sure it's going to be used properly within the new AERMOD 18081. Now, in terms of the low wind enhancements, the options for low wind modeling within AERMOD have been put in place to help refine model accuracy, particularly for stable conditions with very low wind speeds. The original AERMOD implementation was found to overestimate a bit when that happened. So the beta options, low wind 1, 2, and 3, were put in place to help further refine the model. We've now graduated from those. Low wind 1, 2, and 3 have been completely removed. And in place of these prescribed numbered low wind options, there was a joke that they were up to like low wind 8 in the code. We've now replaced those, or the US EPA has replaced those with the new low underscore wind keyword. And with low underscore wind, the modeler will have full control over the minimum sigma V, the minimum wind speed, and the maximum meander factor. And again, adjusting these options is meant to find a sweet spot in the model accuracy for stable, very low wind speed conditions so that we're not overestimating, but we're also not underestimating what those concentrations are that result from that. Further changes to AERMOD, additional enhancements, include some updates to the nitrogen dioxide routines. The old ambient ratio method, or ARM, has been removed. The original implementation of ARM was a single application where you would specify one percentage, and that percentage was applied to all concentrations. It would assume total NOx was emitted, and it would multiply the total NOx concentrations by that 1% to estimate NO2 concentrations. That routine has now been removed, primarily because the science behind the old ARM method was rooted in long-term averages, whereas in the United States, ambient air quality standards have moved towards short-term averages. So the old ARM was not really applicable to a 1-hour NO2 standard. Something like ARM2, which was made regulatory default back in the 16.2.16R release, is more applicable to 1-hour NO2. So we've removed ARM, and we now have equivalent functionality by setting the ARM2 minimum and maximum ratios to the same value. You can replicate the old ARM functionality. ARM2 is now also being applied to buoyant line sources. And then there were miscellaneous compilation updates, renaming some user-defined functions to avoid conflicts in names when doing the compilation, and then an issue with uninitialized variables that has no effect on the model run itself. So those are the impacts, the updates to the AERMOD modeling system. What I wanted to do now was go through and demonstrate quickly for you how you can go about using these new executables in the existing AERMOD View version 9.5.0. I'll talk about our updates to AERMOD View here in just a few minutes. We are currently making those updates as it is right now. But in the interim, if there are projects where you need to start using these executables as soon as possible, we'll take a look at each of the interfaces to see how that can be done. And we're going to start with AERMET View. So here is AERMET View 9.5.0. This is the currently available version of AERMET View. And as I open this up and I go to the File menu, you'll see there is a Preferences tab here. And when you go to Preferences, the first available options are what executable of AERMET, AirSurface, and AERMINUT do you want to use? Now, because the interface was last published at a time when 16.2.16r was the last available model version, that's what you're going to be dealing with by default here. AERMET.exe corresponds to AERMET 16.2.16. But you can go to the EPA website, epa.gov/SCRAM, SCRAM, and you can download the model executables from there. And then once you've done that, you come to this user-specified radio button, and you browse on your computer for the location where you have saved that model executable. On mine, I have done that in the C drive AERMET folder, and I have AERMET.exe, and this corresponds to the 2018 version of the model. So I open that up. It's now pointing to C drive AERMET, AERMET.exe. And if I open up a little sample project that I have here, I'm just going to go with the AERMET View tutorial that comes with the software. The current version of this SFC and PFL file that I've run was run using 16.2.16, as you can see from the version number here in the AERMET output files group. So now when I rerun the model, because I've pointed to the new executable, once it finishes processing, it's now going to tell me that I am running with 18081. We've done some side-by-side comparisons of output files from AERMET between 16.2.16 and 18.081. There's virtually no difference between the two. As I mentioned, there's just some limited bug fixes. The only appreciable change was really that identification of liquid versus solid precipitation code in the surface file. But most of the other numbers should be completely unaffected. Now switching over to AERMOD. In AERMOD, it's a very similar process. So you go to your File menu, go down to Preferences, and now you'll come to the EPA Models Limits heading, and there you have AERMOD, AERMAP, and other models that are available within the application. So for AERMAP, the default points to just the 11.103 version of AERMAP, the previous release. For the user specified, I've pointed it to C drive AERMAP, AERMAP.exe. That's where I happen to install that version of the executable from the EPA. So now that will be using 18.081 AERMAP when I run the terrain processor. Same thing for AERMOD. Instead of the default processor, I'm switched to user specified. And in my C drive AERMOD folder, where I happen to save that executable and extract it, I have AERMOD underscore 18.081 underscore 64 because I'm using a 64-bit operating system. So then I can come and open up any project I want, a tutorial project that comes with AERMOD View. I don't have to make any changes. Now, one caveat, as I've mentioned before, when you plug in the new model executable to the existing AERMOD View interface, you'll be able to run your old projects or create new projects and run them under 18.081 with the exception of the new model options. So the alpha keywords that I mentioned, the alpha low underscore wind, that's not going to be built in here yet. So there will be another mechanism I'll show you in just a second to get there. But in the interface, that option isn't yet supported. It will be when we update the interface. At the very least, though, this will get you running with 18.081 to check out some results. Same with the terrain processor. I plugged in the new AERMAP executable. It's reading that AERMAP.exe from the location on my computer that I specified. So I can go ahead and rerun AERMAP here with the new executable and get the proper output from the new model executable. So I'm running my AERMOD 18081 underscore 64 executable when I perform my model run. We'll come back to this in just a second, as that's going to run in the background. Now, one last mechanism you can use to run AERMOD 18.081 through the existing Lakes interface is to go to Batcher. If you're not familiar with Batcher, it comes with every copy of AERMOD View, and it doesn't require a license if you're just using the serial AERMOD executables. So you can install AERMOD View on multiple computers and take advantage of Batcher to run sequences of input files without necessarily needing a license, and then transfer the files back to your fully licensed computer to look at the output in AERMOD View. So within the Batcher interface, there is a drop-down list of available model executables. You can see these are all numbered based on previous AERMOD releases. I have aermod.exe. I also have the parallelized AERMOD MPI_lakes. And to add additional executables, I just come to this little browse button off to the side, and I add a new executable. So I'm going to go back to my C drive, my AERMOD folder, and add the 64-bit 18081 model executable. And once that's added to the list there at the bottom, I can now select it from the drop-down menu. So now any sequence of input files that I add to the Batcher list here will be run using the 18081 64-bit model executable. I'm going to add a couple of input files here from the EPA test case library that comes with the AERMOD model executable. I'd have to make some adjustments here to these input files because it tells me that there's bad formatting because of the way the files are referenced. But if I then clicked go once fixing those problems, Batcher would be running the new 18081 model executable. This is the mechanism through which, if you wanted to start using something like the alpha low_wind keyword option, you could manually modify your model executable within a text editor, Notepad or WordPad or whatever program you like to use, manually add that option in, come back to Batcher and run it through the 18081 model executable. One last time, going back to AERMOD View, my 18081 AERMOD run is complete. I'm going to open up a contour plot file from that run. And you can see from the header of the plot file as it appears on your screen, it is running AERMOD 18081. So these results represent the new model executable. Having done a few quick calculations with some existing test cases, the differences between 18081 and 16216R have not been great in the limited testing that we have taken on so far. There certainly, I would expect to see bigger changes as I started invoking new model enhancements like low_wind or taking a closer look at some of the NO2 options and stuff. But for base cases that we've looked at, very, very similar results between the two models. Now, the question that many of you have been asking, when will the new AERMOD View be coming? And the answer is it's going to be a few weeks. Because we do not get advance notice of these model releases, we immediately upon their publishing by the EPA have to go in and start making our updates to the interface. And that includes the parallelized model executables for AERMOD and AERMAP, which take a bit of coding to perfect. So once the new AERMOD View version 9.6 is available, an announcement will be made to our in-maintenance users of AERMOD View. If you suspect that your maintenance date is coming, or if it recently lapsed, or if you've been out of maintenance for a little while, I encourage you to contact our sales team, and I will have our contact information up here at the end of the presentation. Some of the new things you can expect to see in AERMOD View version 9.6 include support for the 18081 models, that's AERMOD, AERMET, and AERMAP. Both 64-bit and 32-bit versions of the executables will be supported, along with all of the associated features like the alpha keyword, the removal of ARM, and more. We will also include the new AERMOD MPI and AERMAP MPI parallelized executables, which are developed in-house here by Lakes Environmental. We have to, of course, conduct all of the code updates, the compilation, and then all of the extensive testing that we do to ensure that these parallelized executables produce 100% equivalent output to the EPA models. There will be some new GUI features included. One Little tidbit that of what we're working on includes the import and export of variable emission rate data. This has been a long requested feature. We finally worked out a nice system for using Excel spreadsheets to import and export variable emission rate data for all variable emission scenarios that utilize the source pathway input option. And then we'll have our usual minor updates to the existing features. So again, expect that release to be coming here in the next few weeks, probably targeting sometime in late May, no later than early June. And that's it. Again, if you have any questions about your current maintenance on AERMOD View, or if you need to renew your maintenance, or if you'd like to purchase additional copies of AERMOD View, please contact our sales team, sales@weblakes.com, and they will be happy to help you with that. Since we've gone a little bit over our time here, I won't hold you any longer. So if you have any technical questions, then please send those along to our support team, support@weblakes.com, so we can compile those and we'll get an answer to you as soon as possible. Again, sales@weblakes.com for any sales or maintenance inquiries, support@weblakes.com for any technical questions that you have. I want to thank you all for joining us today. I'm really happy that you could all be here. I hope you got a lot of valuable information out of this presentation, and we hope to be speaking to you in the near future. Have a great day, everyone.